Nicole, and I want to teach you chemistry.
Our whole universe was in a hot, dense state that nearly 14 billion years ago expansion started. Wait, the earth began to cool, the autotrophs began to drool, Neanderthals developed tools, we built a wall. We built the pyramids. Math, science, history, unraveling the mystery that all started with a big bang.
Wait, don't leave just yet. If you give me just a few moments, I can prove to you that not all of chemistry is ridiculously dull, but it's actually this extraordinary science of stuff. As Hank said,
Chemistry holds the secrets to how life first formed, how cancers are cured, how iPhones have bigger hard drives than 5-year-old laptops, and how life on this planet might just be able to continue thriving, even ours, if we play our cards right.
"Hey Dad, what you reading?"
The book about the body.
Hey Dad, what's today's book?
Today's book is a book about the brain.
Let me guess, Dad, a health book.
No, actually, I'm reading McGraw-Hill, Ryerson Chemistry 11, Chapter 11. It's all about how gases are essential for human survival through the use of oxygen tents, anesthetics, and for industrial and commercial uses. Want to read it?
Yeah, sounds cool! Let's get into it. So before we start off, like always, I will be answering some questions that you guys sent in. Okay, so first question.
What even is a gas?
Very good question. A gas, for one, is everywhere. Also, a gas's molecules are really spread out, full of energy and constantly moving around in every which way. Next question.
What are the distinguishing properties of gases?
Gases are compressible, so it is able to be squashed into smaller spaces. Gases are able to expand as the temperature is increased. Gases have very low viscosity, so gases are very thin. For example, H2O. Gases have much lower densities than solids or liquids. And lastly, gases are miscible, meaning they can be mixed together. Human survival. Anesthetic gases are often used in surgeries or when a patient needs a temporary loss of sensation. Since gases have low viscosities, gas anesthetics are super quick to enter the human body. Most gases in today's day are man-made, and there are several types of anesthetics, but today I will only be discussing local and general. Local anesthetics is where the region of nerves are prevented from sending pain signals to the brain. Cocaine, lidocaine, tetracaine, bipivane are administered intravenously, meaning they are administered into the vein. General anesthetics are most often used in hospital settings. It is used to completely knock out the body. Widely used gases include nitrous oxide, which is known as laughing gas, and halogenated gases such as enflurane, haloflane, isoflurane, and desoflurane. Although a positive note is that it is quick to enter and exit the body, anesthetics are warming the planet. Yes, the gases in surgery are contributing to climate change. Gases desoflurane, isoflurane, and sevoflurane have a greenhouse effect that is 2,500 times more potent than carbon dioxide, according to scientists. In Canada, the top places producing greenhouse gas emissions are Quebec and Ontario. Oxygen tents are used mainly for patients who suffer from respiratory problems. A disease like pneumonia or carbon monoxide poisoning can be helped with oxygen tent. If someone is deprived of oxygen, an oxygen tent can help because the gas inside the tent has a higher percentage of oxygen than in normal air. Why do we need oxygen, you ask? Well, oxygen is a part of the air we breathe. Our body uses oxygen to create the energy we need to walk, think, and breathe. Without oxygen, life would cease in less than 10 minutes. What is our atmosphere made up of? Even though oxygen is an important factor to human survival, breathing in pure oxygen is really unhealthy for the human body. It could lead to serious health problems or, at its worst, death.
Humans are only able to take in 21% oxygen.
This comes from the photosynthesis cycle. Plants provide oxygen through this process. Without plants, we are unable to survive. This reaction shows the cycle. 6 CO2, which is carbon dioxide, plus 6 H2O, which is water, adding a little bit of light, which will be C6H12O6, which is sugar, plus 6O2, which is oxygen. Earth's atmosphere. It is a mixture of gases including 78% nitrogen, 0.9% argon, 0.3% carbon dioxide, and 21% oxygen, with other small percentages of elements being included. From this, we can conclude that gases are essential for human survival, industrial and commercial use. Fluorescents are a large family of light sources, and there are 3 main types of fluorescent lamps: cold cathode, hot cathode, and electroluminescence. The hot and cold cathode lamps have a glass discharge tube and a fluorescent coating on the inside. They are commonly used for both indoor and outdoor use, decorative lighting, and signs. Fluorescent lamps work by ionizing mercury vapor in a glass tube. This causes electrons in the gas to emit protons at UV frequencies. The UV light is converted into standard visible light, using a phosphorus coating on the inside of the tube. Fluorescent bulbs use a small amount of electricity to excite the gas mercury vapor inside the tube. The gas then gives off invisible ultraviolet light, which bounces off the phosphorus coating inside the bulb to produce visible light. On a negative note, there is a rising concern over the disposal due to the mercury that is inside the bulb. According to Health Canada, mercury can impair the ability to see, feel, move, and taste, and can cause numbness and tunnel vision. Long-term exposure can lead to progressively worse symptoms and ultimately personality changes, stupor, and in extreme cases, coma or death. Another commonly used light is neon. At the end of each tube, there are electrodes. Gases like helium, neon, argon, and krypton are used. Voltage will cause a free electron to reach maximum kinetic energy. Electric current is passed through the plasma of charged ions and electrons. These come with benefits such as savings, versatility, and convenience, but like everything, has its negative sides. This includes gas leaks, carbon monoxide, and fires. To even begin to understand how fire extinguishers work, we need to know about fire. There are 4 things that must be present in order to start a fire. There must be enough oxygen, heat, a fuel, and a chemical exothermic, which is fire. There is this diagram many people use as a guide. This diagram is called the fire triangle. The fire triangle contains the 4 elements that we just discussed to create a fire, hence the name fire triangle. It is important to remember that all 4 elements must be present in order to start a fire. If one of these elements are missing, there will be no fire, and this is where the idea of a fire extinguisher comes in place. Basically, a fire extinguisher will take away one element from a fire, and that's carbon dioxide extinguishers are full of non-flammable carbon dioxide under high pressure. Carbon dioxide extinguishers will displace oxygen, which will suffocate the fire and put it out. CO2 extinguishers may displace too much oxygen from the air and then may lead to some serious health problems. So today I'll be asking you guys some questions. No, I am not asking you questions. Take 50 with... I was so good until I messed up. Oh, I've been filming this whole time. Since gases have low viscosities, I totally just showed you my paper. Thank you, Lord.
Since gases have low... What did I have?
Gases! Are you kidding? I wasn't recording.